Let's go back to the beginning. Last year, in fact, to a world that was in the glory days of the information age. Information was everywhere.
Ich liebe dich.
So much, in fact, that we were swimming in a virtual ocean of it, with wave after wave bringing in more every day. Our curious young student reveled in it. His phone could seemingly answer any question that popped into his mind. Or so he thought. It turned out that for his most important questions, how to eat healthy, what school should he attend, the more he waded through this vast sea of information, the more confused he got.
This is complicated.
Where could he find the answers? Where should he invest his time? He tried to learn p-values, r-squared, regression analysis, and more. It was so complex, it seemed to be written in code that made no sense to him.
What is this?
The answers to his questions seemed further away than ever. Eventually, he came to the conclusion that traditional methods would get him no further. He would set out on a quest, traveling the globe to hunt for the answers that these methods couldn't provide. For nearly a year, he traveled through the world's remote regions, seeking out wise men and women, studying ancient artifacts, and unearthing arcane legends.
Shiny.
Throughout his travels, he continued to find clues of a remote place, a place of learning, and of a man who could swim through this sea of information, a man who knew how to find the answers, a master of metrics. After struggling for so long, it seemed he had finally found his destination. Which brings us back to now.
Is there really a master who can teach me to find the answers I'm looking for?
Indeed. It is Master Joshua you seek.
Master Joshua.
Yes. In the outside world, he was known as Josh Angrist.
So he's a master of data science and statistics.
Oh! There is so much of this noise in the world. So much confusion. The answers you seek... The answers you seek are rooted in a simple but deep concept. Cause and effect. It is only through econometrics, the original data science, that you can come to know the path from cause to effect. And in order to grasp econometrics, you must learn to master the legendary Furious Five. These are the primary weapons used in econometrics. Without... The journey of 1,000 miles begins with one step. Mastering Econometrics is a free online course that teaches you how to use the legendary Furious Five. Econometrics is a journey, Grasshopper. Click to start yours today. Welcome. You have traveled long and far, through jungles and deserts, to learn econometrics. Today, you take your first step towards becoming a metrics master. We will be studying the teachings of Master Joshua. He built all this. Our first lesson is not for training your hands, but for training your mind.
Our metrics path leads to choices and consequences. But the way of metrics begins with questions. We consider questions of world-shaking importance. But some of our most interesting questions are personal. What to study, where to work, whether to marry your sweetheart. Here's a question you might have considered already. Should you go to an expensive private university like Carnegie Mellon or Duke? Or should you save money by going to your local state school,
So I know
say
that a bunch
Penn
of
State
you,
or
maybe all of
UNC?
you, hopefully all of you, or you hope all of you are future instructors. So I always take advantage of this opportunity to show my new video series, which is part of Marginal Revolution and University, and they have tons of great video content, and I'm helping them beef up the econometric side of what they're doing, which is until now pretty lame, but now it's awesome. And so I'm just giving you a taste of that, and you can use that for free in your classes. As usual, the AC at Harvard is definitely questionable. We have the same problem with the dark. If you see if the temperature will go down. I got it. So let me get started because I have a lot of ground to cover, and I know some people have to leave at 1, so I want to get as far as I can. But I'll keep going after that, and then probably eat lunch around 1:15. So it's nice to be back here and talking about school choice. Very controversial, always controversial school choice in K through 12, and timely. Cambridge is a big part of that story. In fact, they have ongoing issues with the school system in Cambridge and how their match should be designed and how kids should be assigned to schools. Those of you with school-age children would kind of live this personally, and we live it because we provide assistance on the matching technology. We being a group of scholars at MIT, we're called the School Effectiveness and Inequality Initiative, and we do a lot of work on market design problems and how they intersect with research design. And this is really part of an ongoing agenda that Parag Pathak and I have been pursuing with colleagues and students for about a decade. Today we're taking a different dimension of the school agenda, one that's very controversial, somewhat tangential to the methodological concerns of our earlier work. This paper is motivated by affirmative action, though it's not completely targeted at affirmative action. So affirmative action policies give underrepresented minorities a leg up at selective schools, most famously, Harvard Law School, places like that where there's a debate about how many minorities are at those schools and how hard it is for them to get in and whether there should be some special consideration. In the K through 12 sphere, which is where we do our work, not in higher education, AA arises in the context of exam schools. So very famous scenario in Boston. Boston has 3 highly selective exam schools. Well, they're ordered by selectivity. The most famous is Boston Latin School, where many of our social science alumni, distinguished alumni studied. And there's 2 other exam schools, Boston Latin Academy and O'Brien. New York has Stuyvesant, Bronx Science, and Brooklyn Tech. And then it actually has hundreds of selective schools that are not as famous as those 3. And they're all kind of coordinated through a very large and complex match. Chicago has now 9 selective exam schools, 10. It had 8 at the time we started this work. And that includes some very famous schools. If you have friends at the University of Chicago, they're probably trying to get their high school age kids into Northside and Peyton. Michelle Obama went to one of the Chicago exam schools. And again, they have a kind of a distinguished history. So, these schools have a long track record of being central in American public policy debates about schools, even though they're not quantitatively important. They don't account for a very large fraction of enrollment, but they seem to be in the headlines often. And in particular, many observers, including the superintendents of these urban districts, have commented on the fact that minority representation is low. And so affirmative action policy is an attempt to make the schools more accessible for groups defined by race. Now, that's actually not allowed anymore. The Supreme Court ruled out explicit quotas in 2007, and that's an important piece of context here. So today, affirmative action in exam schools uses socioeconomic criteria that are thought to proxy for race or neighborhood, criteria, and of course may be of intrinsic interest as well. So the question that this paper addresses is whether the Chicago exam school beneficiaries of affirmative action, and we have a pretty good idea of who those people are, whether that group indeed benefits in some measurable way. And the way that we're measuring it, and you might quibble with this, but that's what we're doing for now, and we'll do other things later, is achievement. So we have test scores in the period following admission to the exam schools. And we use that as our measure, okay? Now, of course, I said people have very strong views. So here's Richard Carranza, very recent story. And he was also at MIT a few months ago at an event we convened on school choice. And he spoke mostly about access to elite schools for minorities. And the poster, like, the headline here is that there's, I think, 7 African-American students admitted to Stuyvesant out of about 1,000. So there's a huge media attention on that. Our own Boston Latin School often turns up in the same context on the editorial pages of the Globe. And as we speak, the candidates for the superintendent of BPS are being interviewed over in Roxbury. And they're being questioned about what they're going to do about low rates of minority admission to exam schools. So that's always very central. Of course, parents care a lot about this. So we were over at BPS yesterday, and we met with staff, and one of the staff herself has a child at Boston Latin Academy, and she's very pleased about that, even though she's ambivalent about exam schools as a matter of public policy. Here's a sort of a stylized version of that. So in New York City, parents would like their children to go to Gotham Academy. Gotham Academy is a fictional but otherwise realistic version of what New York City folks call a screen school, so it's hard to get into, and you have to have adequate test scores. And of course, Gotham Academy is appealing to parents because it has very distinguished graduates, and everybody knows all about the wonderful graduates of Gotham Academy. Now, we might think, well, that's as may be, but to some extent, that's a mechanical thing, because you don't get into Gotham Academy if you're not a high-achieving student. That's how they do their admissions. So the fact that their graduates do well is no more informative than the fact that Harvard graduates do well or that MIT graduates do well. We don't let people in to our PhD programs and our undergraduate programs at elite universities if we don't actually predict, based on all sorts of witchcraft that the admissions offices do, that you're likely to do well. So that's certainly not evidence of a causal effect, but families, ordinary citizens, have trouble sorting that out. We have a strategy to sort it out, and we've used this in a series of papers. And we do that with a kind of a local RD thing, but I also have a bit of local context here. Now, this is my version of the theory. So the theory behind a lot of the theory behind the debate about affirmative action is what's called the mismatch hypothesis. And in fact, that was promulgated by a legal scholar named Sander. And he kind of articulated that. And the Supreme Court cited that when they ruled out explicit racial quotas. And generally, social scientists, tend to be in favor, like most academics, generally liberal, generally in favor of affirmative action. On the other hand, if you look at our own programs, so we have the pleasure of running elite programs, we completely subscribe to the mismatch hypothesis in the way that our own programs are run. And you can see that in the fact that if you take the MIT and Harvard PhD programs, we have very few African-American graduates, almost no African-American men. And that's because not many from that group get into our programs. Why don't they get in? Well, first of all, as I tell my undergraduates, it's a zero probability event. Nobody gets into the MIT economics PhD program. You should assume that's true for you. But ex post zero probability events happen, and somebody gets into our program, even though they have a measure zero. Now, if you look at that kind of super select group, you see that minorities are underrepresented. And that's because our bar is so high. It's just too high for many minorities who generally have lower test scores, lower GREs, lower grades to clear. And why don't we let them in? We should lower the bar. I'm always saying that, by the way, so I'm consistent on this. I would like to change the way we do our admissions, but my colleagues are not having it, and that's because they subscribe to the mismatch hypothesis, which is if you're not, mathematically precocious, in particular, that's what we screen on in economics admissions. It's basically one big IQ test. You're not going to do well because you're going to be out of sync with the material and you're going to be out of sync with your classmates. Well, that's what Sanders said about Harvard Law School. That the level is very high, and if we just start letting people in willy-nilly, they won't do very well. So that's a kind of a touchstone in the debate, and that's where our kind of pitch on this. That's why we call this paper a paper about mismatch, because we're going to dig into the mismatch hypothesis, and we're going to show clear symptoms of mismatch at Chicago exam schools in the sense that the mostly minority marginal applicants don't do very well there. The causal effect of exam school admission is 0 to negative. It's actually statistically significantly negative for math. Why is that? Well, maybe Sander was right. If you're sort of marginal at an exam school, it's not for you. Just like we said, our PhD program, if you're a marginal college student from Oberlin College, like I was, it's not for me, okay? So, but that doesn't turn out to be what's going on at all. The story is, in many ways, much simpler, and we have an alternative, and I think interesting story to tell. So, lots of kind of research context here. I'm not going to go through it. There's a literature on exam schools that my colleagues and I have contributed to. There's a literature on mismatch. There's a literature on program and school substitution. So when you let somebody into one thing, they don't go somewhere else, and that's an important part of identifying causal effects. There's, of course, a literature on affirmative action and how to proxy affirmative action with race-neutral rules and the direct effects of affirmative action. So there's a bunch of papers, okay? Now, this study is set in Chicago mostly, but my encore, if I ask for an encore, my encore is Boston data, okay, which we're in the process of kind of clearing. Okay, so I'm going to start by telling you how Chicago works, how the Chicago match works. So Chicago has 10 selective schools. These are public schools, of course, and they're distributed around the city. And my friends who teach at the U of C down here but live in Lincoln Park up here, they want to get their kids in, and for the most part, they do get their kids into like Northside or Peyton. Okay, and that's what the non-Hispanic, non-Black population especially is looking to do. But of course, there's also many minorities at those schools because Chicago is almost entirely non-white district. Now, how do they do their admissions? It's actually centralized. This has just changed. So now the entire CPS system is centralized through a system called GoCPS. But in our period, it has a separate match for the exam schools using a version of deferred acceptance, which is simplified. It's called serial dictatorship. That's deferred acceptance without priorities. Basically, kids order their schools, they can rank their schools, and they get into the highest ranking school. You kind of go down the list of your schools, and if there's capacity at that school, after you've been ordered by the tiebreaker, okay, which is some sort of test score GPA composite, you get the first seat on your list where you're qualified, okay? And you're qualified by virtue of having a high value of that tiebreaker. So I'll come back to this and give you more detail on this. So the CPS default is a traditional neighborhood school. You have this single offer serial dictatorship match in the exam sector. And before GoCPS, there was a whole bunch of decentralized admission systems at charter schools, magnet schools, and also something called a military academy. And now that stuff is all organized. Actually, the exam sector is still separate. So the exam sector works, kids take a test, and they rank up to 6 schools, and then there's a tiebreaker, and the tiebreaker is a composite that weights the test scores on the exam admissions test. 7th grade test, that's tests taken earlier. Exam school seats are 9th grade seats. and your GPA, and the test score is scaled from 0 to 900, okay? And initially, the way I report that, higher is better, but then I'm going to turn it into a rank, and so lower will be better. So when we get a little more formal, low will be better. Now, CPS affirmative action no longer uses race, so it's place-based. And the way that works is CPS, Chicago City census tracts are assigned a score, and the tracts are classified into tiers, and tiers get equal numbers of seats at each school in a proportion of the seats that's kind of an AA reserve, and then the balance of the seats are purely based on the tiebreaker. So there's kind of a set aside where it's guaranteed to be equal numbers of seats for each tier. So that's kind of like priorities in DA, but not exactly. And then there's 30% of seats remain what they call merit-based, which just means that they ignore AA. Here's the map of the tiers. You can see people are, tier 1 are the lower income tracts, and a lot of those are in the south central part of the city. And then you have the higher income tracts. Some of those are in the far west and many in the north. Okay, and I'll talk a lot about low tier, and when I say low tier kids, I mean kids from tiers 1 and 2. Okay, because those will be, as I'll show you shortly, those are where the beneficiaries of affirmative action come from, and any kind of extension of affirmative action, those marginal seats are going to go disproportionately to the kids who live in low tier kids. Okay, here's how it kind of plays out. Okay, let me give you two kind of words here that I'm going to use over and over again. One is a tiebreaker. Okay, so tiebreaker, and the tiebreaker is just, that's our way of referring to the thing that's used to prioritize students as they apply. So it's the test, or in this case, it's a composite, a weighted average of test scores and grades. Okay, and this is showing you the second thing, important word, is cutoff. It's showing you the cutoffs by tier and school. And the cutoff is the composite or the tiebreaker value of the last kid admitted. And then also on this graph, we have the median tiebreaker value of enrolled students. So the schools are ordered by selectivity. Okay, so Peyton and Northside are the super selective. These generally are thought of as the elites. And then there's less elite. I think Michelle Obama went to Young, actually. So you could see the median tiebreaker value of enrolled students gets higher as we move to the right. The black bar is what you would get for a cutoff. That's the tiebreaker value of the last kid admitted after you run the match. And I say admitted but not enrolled because the match offers seats. Enrollment is endogenous. Kids can take their offers or decline them. So what's mechanical is the offer. Okay, so the black bar is where the cutoff would be for everybody in a world without AA. But because of AA, the cutoffs are low at the elite schools by quite a bit. The cutoffs are low at the elite schools by quite a bit. So that blue dot there is the actual north side cutoff for tier 1 applicants to Northside. Okay, they have Northside on their list. And then tier 2, the cutoff is not lowered as much. And here you have to raise the cutoff a bit for other kids. And sometimes the lowering of the cutoff produces a raising of the cutoff at some schools, a noticeable raising, like at Lane and Young and Jones. Okay, the cutoff has to be higher somewhere if this is all going to balance out because it's a capacity constraint system. They don't add seats. So if they're making it easier for somebody to get in, you're making it harder for somebody else to get in. That's a fact about affirmative action policies that are built on a system where capacity is fixed. Of course, you could propose to add seats and open more schools, but that's not the system that we receive for research. The system is fixed. Okay, so everybody see how that works? So that shows you that AA does something here. And what it does is it lowers cutoffs. And that's kind of a useful bit of background because RD, which is our research strategy here, regression discontinuity, is about comparing kids that are marginal to cutoffs, which is kind of like lowering the cutoff. Okay, I'm gonna let you in. You don't clear the cutoff in the sort of AA neutral world, but I'm gonna let you in, okay? Well, looking at that lower cutoff, we're finding out whether people who are marginal to the no AA cutoff are benefiting from the time they spend in exam schools. Okay, so that's the research strategy. Okay, so everybody kind of clear on the institutional background? I realize I'm going fast. All right, so here's the first thing. We kind of do this in two acts. We're going to use all this data. Okay, we have a lot of data. We want to solve the selection bias problem. So here's my Batman metaphor again. Poison Ivy is our nemesis, or she's no, she's not our nemesis. She's our secret weapon. And we're going to use the Chicago admissions test score data for 3 cohorts of applicants to study the effects of exam school enrollment. So we got great data here because we worked with the district and we helped them design their match. So the current Go CPS system is partly the fruits of work by Attila Abdulkadiroglu and Parag Pathak. And so we get some access to research files partly in support of that work. And we have the 2009 is the interesting period to start for us because that's when the exam school system kind of becomes organized. Okay, it's hard to say how it was done before, but we know how it was done since 2009. And we also, in particular, the thing that's harder to kind of piece together is how they did affirmative action in that earlier period. And so now we know exactly how it works. And then our outcome variables are grade 10 scores, those are called plan. And grade 11 scores, those are actually ACTs. So ACTs are the Midwest SAT. That's what a Midwesterner takes, to get into college. So that's actually a great outcome because it's a meaningful test. It's not just an accountability metric, but it's consequential for the students, or at least some of them. Then we combine that with applicants. At this time, this is pre-Go CPS, so the system is partly decentralized. So there are separate lotteries for magnets, and there are separate lotteries for charters. So we combine that exam school sector with data on applicants to magnets and charters. And the reason for focusing on those two sectors is part of our story. Okay, so you'll see why we made that decision. Here's some statistics on the district. Okay, as I mentioned, not very many whites in CPS. Well, let me just say the first thing is these statistics are broken down by sector. So you have your traditional schools, exam schools, that's the 10 selectives. You have magnets, you have charters. CPS has a lot of charter enrollment. This is 9th grade only, by the way, okay? So you have about 90,000 traditionals, but you have 17, 18,000 charter kids. And the largest charter provider in CPS is Noble. And that's why we collected that group in particular, because Noble, even though it's decentralized, Noble centralizes their data. So they're actually a kind of a network, a sort of school district within a school district. Then you see magnets have about 5,000 kids, and the exams have about 10% of enrollment, or a little bit less. So I think it's 105,000 total. No, it's more than that. No, roughly. Okay, now demographic facts. Not many whites, so most kids are Black or Hispanic. Charter schools have more African American than Hispanic. That's not unusual in large urban districts. A handful of whites and Asians. Most kids are poor enough to qualify for free or reduced price lunch. Okay, a lot of special education kids, especially in the traditional and charter sectors. Then you have the tier distribution, which is roughly equally weighted across tiers because that's how it's designed. District-wide, so the test scores are always standardized to the district, so district-wide scores are close to 0, but since I'm looking at the traditional here, it's going to be slightly negative because I'm taking out high-achieving exam school kids. Okay, so exam school 9th graders are about 1.4 standard deviations above the district mean, and that's, again, kind of by construction. Charter kids are highly negatively selected, and we'll see if what that should mean. Again, this is baseline, so it's not an outcome. It's a 7th grade score, okay? And these are high schools. Okay, any questions about that? So that's the kind of statistical picture. Now I want to give you some of our power tools. So we have a whole set of tools to study causal effects in settings where there's this kind of matching going on. We published a paper a couple years ago about how to do that in districts that use deferred acceptance with lottery tie breaking, which we like a lot. So if you come to us and say, how should we do our enrollment, we'll always say, well, DA is good because it's strategy proof, and then for a tiebreaker, you should just draw a random number. But of course, that's not the, and that's good for research. We also think that's good for public policy. But of course, that's not the spirit of exam schools. Exam schools are using some measure of ability or merit, and that's the tiebreaker here. Okay, so we need tools to study that. So I want to use that kind of non-lottery variation. So I need to really explain a little bit of this for you to have an understanding of why we do things the way we do. So I give a little math here, but you can skip this in your mind if you want. And the main thing is just remember there's a sort of some statistics that are relevant, okay? So the first thing that's relevant is type. Your type is the thing that's not the tiebreaker. In this case, it's your preferences and your tier. So the match looks only at these things. It looks at your type and the tiebreaker, and then you just run a computer program and you find out who gets offered a seat where. Okay, so the matching is mechanical in that sense. Then you have this idea of cutoffs. So the cutoffs are tier specific, as I showed you in the figure, and they're type specific as well, though that's not reflected in the figure. So there'll be a cutoff for a particular type and a cutoff for a particular, there'll be a cutoff for a particular school and a cutoff for a particular tier. So that's why theta is there. Sorry, that's why theta is there. It's not, the cutoffs are not a function of priorities, of preferences. Okay, then the notation for the tiebreaker is R. And a second kind of piece of, notation here is what we call most informative disqualification. So this is very useful to us because the matching in principle is very complicated. It's a mechanical function of your preferences, and then how many ways are there to, order 6 things? There's a lot of ways to do that, but we don't have to keep track of all that. We only have to keep track of the easiest school to get into, and that's because there's a single tiebreaker. So when we're asking what is the probability that you get offered a seat at school S, the only thing I need to know about other schools on your preference list is among the schools that are ahead of S on your list, what's the easiest one to get into? I need to know that school's cutoff. Because if you can get into the school that's easiest to get into among the schools that are preferred to S, you won't get an offer at S because you qualify at a better school. Okay? And since you qualify at one of them, you qualify at some of them. Okay, maybe you qualify at others that are not the easiest schools. So that statistic is mid, okay? So mid is the highest cutoff in your better set relative to S, and your better set is the set of schools that you prefer to S, okay? That the serial dictatorship offer indicator can be coded like this. You get an offer at school S when your tiebreaker, and now I'm using rank, and so low is good. So a little normalization switch there. Okay, I'm using rank instead of raw numbers. So low is good. So you qualify at S and you can't do better. Then you get an offer at S. Okay, and that's going to become our instrument for going to S. Going to S is still a choice. People accept or not accept their offers. Okay, here's just a visual on that in the data. So this is the enrollment offers and enrollment rates. So offers and enrollment rates for the 373 applicants to King whose mid is given by Brooks. Brooks is a more selective school than King. Okay. So if you qualify at Brooks, and that's the easiest school to get into that you prefer to King, you'll never be offered a seat at King because you can at least get into Brooks, maybe a school that's even more selective. Okay, if you don't qualify at King, well, you're above the cutoff. You won't be offered a seat at King. Everybody in between is offered a seat at King. Okay, now the take-up rate's not that high. Lots of people get offers and they don't take them. They end up going to their neighborhood school. So the take-up rate is about 0.4. Those are the enrollment rates, which is why we're going to need to do IV. So the empirical strategy in this paper is to look at people who are near these two cutoffs. And what this does is it tells us which cutoffs to look at. Okay. So if we want to know how to quantify risk at school S, we need to look at people who are near the cutoff at S, but we also need applicant by applicant, they're mid. And that solves an important problem in this context. The propensity score for this problem, which is the risk of being seated at S as a function of my type, is the probability of this event. And by the propensity score theorem, controlling for this would eliminate OVB from theta, but we have a problem. There's no dimension reduction here because the tiebreaker distribution is an unrestricted function of theta, and because we have bias from Ri. So that's why we go to that kind of local idea, okay? And we look at people near those two cutoffs. So there's a schematic of it, okay? I think actually I probably do too much on this. Okay, so the idea is that two sets of in-bandwidth applicants have risk of a half. So this is another kind of twist on the original RD idea. The original RD idea is that you want to say the conditional expectation function of outcomes is smooth. Here what we're saying is it's a randomized trial once you're close enough to the cutoff, and that's because any continuous distribution is locally uniform. That's kind of calculus. It's an infinitesimal result, but it is actually true-ish in our data. Okay? So here's a version of that. These are Westinghouse. That's one of the exams. This is the probability of falling below the cutoff at Westinghouse. And here I'm looking at kids who have below the math median, above the math median. That's baseline. Okay, that's baseline. And of course, if you have a high baseline score, you're much more likely to qualify than if you have a low baseline score. But then as I narrow the bandwidth, so here's a bandwidth, it's arbitrary, but it's an IK bandwidth, those risk numbers are moving closer. And then if I take half that bandwidth, they're closer. And if I take 0.1 of the original starting point, so now I'm down to 100 left and 122 right, even though they have very different baseline scores, you know, calculus is true, and this is happening in our data. Okay, that the probability of being offered a seat or clearing the cutoff is empirically balanced. Okay, so that's the big kind of way we do this, but the twist from the match is that there's a bunch of cutoffs we should look at. We should look at your mid as well as the school-specific cutoffs. Okay, now here's the kind of the additional details on the setup. The instrument is a dummy for being between those two. We also have a just identified version of this where instead of individual school offers, we can say, did you get any offer? Well, you get any offer if you, as long as you clear the cutoff at some school that you rank. Okay, so let's take the easiest one again. Among schools that you rank, that's your qualifying cutoff. As long as you clear at least one of the cutoffs, a cutoff in the set of schools that you rank, you're going to get an offer. And so we can just look close to that. So that'll produce a single instrument instead of school-specific instruments. Two-stage least squares uses local linear control, etc., that kind of thing. This is a version of double robustness when we put that in. And I'm going to skip the details, but it works in the sense of balancing covariates. And also, kind of surprisingly, there's not a lot of attrition. There's not a lot of differential attrition between people who do and don't get exam school offers, which is something you would typically worry about in this kind of paper. Okay, so the instruments are either individual school offers, which is useful because the schools have very different compliance rates. People are more keen to take an offer from Northside than King. Okay, the more selective schools have higher take-up. Or it's a just identified model with a single dummy instrument. So it's two-stage least squares. The thing we're instrumenting is years enrolled in an exam school. So that deals with the fact that people leave exam schools. They don't like it or they move. Okay, and so they need to go to a different school. And then the instrument in this, the way it's written here, this is just the qualifying cutoff instrument and then you have polynomials that control for tiebreaker, and that's written out there. Okay. Now we're also going to add additional sectors, but I'll have more on that later. One thing that's kind of interesting is who's compliant with these offers. So it's kind of by construction, mostly non-white students, because that's the way the district is. It also looks a lot like the population that's affected by affirmative action. So we can simulate and say, okay, these are the kids that would get a better offer under more generous affirmative action policies or the existing affirmative action policy, and look at the distribution of those guys. Okay, so here's the basic set of results that kind of set the stage. Here's the first stage. There are different first stages for each sample. There are different outcomes: plan, math, reading, ACT, math, reading. So 4 outcomes. And this is above the qualifying cutoff. So the first stage produces an additional 0.57 years of exam exposure. Okay. Being offered an exam school seat produces an additional 0.57 years of exam exposure, and it reduces math achievement by about 1/10 of a standard deviation. So this is not the desired effect from the point of view of students and parents. I don't know about students, but certainly parents, okay, did not think this is what should happen. The reading ones are not significant, but the math ones, that looks like there's something there. And especially if so this is using the qualifying cutoff, so that's a just identified model. If we over-identify and use school-specific offers, those are now pretty precisely estimated. So minus 0.08 with a standard error of 3 and minus 0.54 with a standard error of 0.02. Okay, so this is, Sander was right. You send these marginally qualified kids to exam schools and they struggle. And actually they learn less. Okay, this is consistent with that. Is that what's going on? So let's dig into that a little bit. Okay, so one thing we can do is we can look at the elite and non-elite schools. So here is a model that allows the effects of elite enrollment to differ from the effects of non-elite enrollment. And, maybe, so actually, elite enrollment reduces reading significantly, at least on plan. The math effects are both negative and about equal, and here it goes the other way. So, not a slam dunk for Mismatch, right? Mismatch says the harder the school, the more negative the effects, right? But that's not a slam dunk for that. How about by tier? So the tier kids are kind of less qualified, and they're the low tier kids are the AA beneficiaries. So again, you say, well, maybe. So this is a little bigger than this in the sense of being more negative at the low tier kids. And here it's definitely, that's the significant one, and this is not. But of course, none of these would be significantly different from one another. They're noisy enough that this might not be meaningful. So if you're looking for it, you'll find it. But that's not clear that it's really a statistically meaningful result. We also do a kind of a direct above and below the median. So here's exam years above the median. So you'd like to see a positive interaction there. And you see that, so if I'm above the median, and again, this is median baseline, if I'm above the median baseline, then I do have that positive interaction here, but not on the other outcomes. So it doesn't sort of look terribly consistent with Mismatch. Okay, so far, kind of end of Act 1. Earlier, kind of across the board in Boston and New York, and this is from an earlier paper, exam school effects are negative. CPS exams reduce math scores. Could be mismatch. The fact that it wasn't negative in those other cities is saying, well, if it is mismatch is not a theorem. Plus, when you look at schools ordered by selectivity, and you interact with tier, and you interact with median, it's either weakly consistent with Mismatch, or we would say, pretty inconclusive. So what's the story with that? What's explaining that? Okay, and so the answer is, I don't know. Now Game of Thrones, of course, is back, but in the intervening 2 years, we had to find other things to watch. So I watched The Last Kingdom. And in The Last Kingdom, the motto of The Last Kingdom, which is pretty good actually, even by Game of Thrones standards, the motto of The Last Kingdom, which Uhtred, the hero, he's Danish, half-breed, lives in England in the early Middle Ages. His motto is "Destiny is all." Okay, well, it's hard to argue with that, but it's also true in this paper in a kind of precise sense that I want to explain to you. Okay, for us, your destiny is defined for a set of compliers. It's where you're going to end up in the counterfactual world where you don't get an offer. So an exam school complier is somebody who enrolls in an exam school when they're offered an exam school seat. Then you want to say, well, where does that person end up when they're not offered an exam school seat? And CPS has lots of sectors. Okay, so it could be a traditional school, but it could be a charter school, it could be a magnet school, it could be a military academy, etc. Okay, so this is a knowable thing. It's identified. So the way it works is you define a random variable, wi equals j, that indicates enrollment in sector j when I do the 1 there. So j counts the sectors or indexes the sectors. There's a potential sector variable. W1 is where I go when I'm offered a seat. W0 is where I go when I'm not offered a seat. And now I can construct a dummy for the likelihood of going to an exam school, in particular, whether I'm offered or not offered. Okay, so W is for all the sectors, and then C is specifically the potential assignment status vis-a-vis exams. So C0 is whether I go to an exam school when I'm not offered an exam school seat. C1 is whether I go to an exam school when I'm offered an exam school seat. So exam school compliers have C1 greater than C0. And that's the population of interest in an instrumental variables problem. We're interested in the distribution of W0s for those people, where they're going to end up when they're not offered an exam school seat. Okay, and they're identified by a simple two-stage least squares procedure that's detailed in an earlier paper. And this is what you get. Okay, so these are the counterfactual destinies for all applicants. The largest destiny by sector is traditional CPS, but the second largest is charter, and about half of that is noble. So the most important non-traditional fallback for exam school applicants, in other words, after allowing for the fact that quite a few of them go back to the traditional sector, most likely their neighborhood school, but if they don't do that, the bulk of them end up in a charter school. So the charters play a huge role here for exam school applicants as a counterfactual destiny. Some also go to magnets, so that's the next largest traditional sector, and then other sectors are kind of small. Magnet applicants, of course, are particularly likely to fall back to a magnet, and noble applicants are very likely to end up in a charter school, particularly noble. So the little line there is telling you how much of the mass is noble. So one story that might explain this is the effect of going to these other districts. I'm not districts, sorry, sectors, because what I'm comparing here is not exam versus traditional, but it's exam versus a mix of all these alternatives. And we know from other work that noble type charters, those are what we call no excuses charters, like KIPP and like the Match School in Boston and the Up Network in Boston and Strive in Denver. Those are good schools, at least in terms of achievement. They boost achievement. Okay. So alternative to the Sanders story is the thing that drives the negative effect is sector substitution. Luckily, we have a strategy for getting at that. We can just estimate a multi-sector model. So we're going to clean up the counterfactual by pulling out the two leading alternatives to non-traditionals. And the two leading alternatives to non-traditionals are charters and magnets. Magnets are 4 schools with specialty programs, 4 high schools. In our period, they had their own decentralized lotteries. There's some detail here. Some of you may remember a paper in Econometrica in 2003 by Julie Berry Cullen, Brian Jacob, and Steve Levitt that was about Chicago magnets. That's this sector. And they looked at the causal effects of going to a Chicago magnet. Then the other big fallback here is Noble. That's the largest CPS charter operator with 40% of CPS charter high school enrollment, and again, decentralized lotteries. And as I mentioned, this emphasizes no excuses pedagogy. No excuses, maybe it's an unfortunate label. It's not about the kids. Some people think, oh, that means the kids are held to strict discipline. There is an emphasis on discipline and comportment, but the school, the no excuses thing comes from the idea that the school should not make excuses like, well, you know, the reason my kids are low achieving is because they're from low income households. That would be kind of the excuses that are not allowed, one of them. And no excuses pedagogy is a kind of package, long day, long year. Full disclosure, my daughter teaches at Up Academy in Dorchester, and she is far and away the hardest working Angrist across all generations. So she gets up at 5, and she's at school by around 7 in the morning, and she stays there until 5 or 6, and then she takes calls from parents in the evening. Long day for the teachers, also long day for the kids. Her school year starts on August 1st, so we can't have family vacation in August. Other things that these schools do is they have a lot of data-driven instruction, so they videotape teachers, they observe teachers, they have a lot of supervisor feedback, they do a lot of tutoring, and they have some low-stakes rewards and prizes. Okay, so you might think that Noble would be good, and so let's see if that's part of our story. You can see hints of the Noble thing. I'm going to skip that earlier one, and the role of substitution here. So here is the running variable. That's the tiebreaker for an exam school around the qualifying cutoff. And this is for the subpopulation of Noble applicants. And so the black line shows that when I clear the qualifying cutoff, there's a big jump in my years of exposure to an exam school. And then what's declining for these guys is their Noble enrollment. Okay, so that's kind of a set of first stages for both Noble and exam, but it's all around the exam school cutoff. And then here, sure enough, the test score falls as you clear that cutoff for this population. So is that kind of phenomenon big enough to explain what's going on in our data? Okay. So here's how we set that up. We have 2 endogenous variables. I'm skipping some of the details here. We have 2 endogenous variables. We add magnet exposure and Noble exposure to the basic 2-stage least squares model that I showed you earlier. So now there's 3 endogenous variables. There's years of exam exposure, years of Noble exposure, years of magnet exposure. These models are identified because we have the exam offers. There's 8 or 9 dummies there in our period, okay? And we have then the lottery offers and the lottery offers for the magnets and charters. So we can use all that information and, okay, I don't want that. We can use all that information to kind of tease these effects apart. So that's Act 2 of the story, okay? And here you see the substitution patterns that make me think that this is a plausible scenario. The effect on exam years of an exam offer is big, okay? This is for all of our applicants. Magnet offers reduce exam school enrollment. Noble offers reduce exam school enrollment. What about the effect of a Noble offer? What about the effect on Noble years? Exam offers reduce Noble years by 0.2. Magnet offers reduce Noble years by 0.07. And Noble offers increase Noble years by 0.7. Then over here, if we look only at Noble applicants, exam offers reduce Noble years by half a year. So there's clearly a lot of cross-sector substitution here. The own sector first stages are the largest, but an exams offer induces substitution away from competing sectors, reducing magnet enrollment by about 0.15 and reducing noble enrollment by about 0.2. Not entirely clear that the noble effects are large enough for that to turn into the negative effect that I was showing you earlier. Okay? Well, turns out that it is. Okay, that's kind of the punchline. So we get the punchline before you have to leave, Chris. And you can see that here. So here is our multi-sector two-stage least squares setup. When we don't break out the counterfactual destinies and we just do exam years, here's the just identified model. Exam years reduce achievement by 0.11. Here are the school-specific offers. Exam years reduce achievement by 0.16. But then when we add as additional endogenous variables, magnet and noble, so now the exam school effect is versus mostly traditional, because we've pulled out the effects of the two largest destinies that are not traditional, the exam effect disappears. The noble effect is so large, on the order of 0.4 here, 0.36 here. It's there also for reading, but that original negative is not very precise. Okay, and then here for math on the ACT, the noble effect is so large, and there are enough people that go to noble that the negative exam school effect is explained in this two-stage least square sense by the presence of noble enrollment in the counterfactual. Kids who are not declining, accepting an exam school offer, a lot of them came from noble, and they actually would have learned more there, even though they're super happy that they got into an exam school. So there's some irony in these results. Again, I can think about my daughter's school, which is a middle school. They're very proud that they get a lot of their graduates, middle school graduates, into the Boston Latin School. It's not clear they should be proud of that, because the ones that don't go to the Boston Latin School might go to Match, which is a charter high school. And here the charter effects are so large that, and there are enough people that go, that this turns out to be our story. Okay. So, what else can we say about that? Okay. Here is kids who also apply to Noble, and sure enough, if you look at kids who apply to Noble, you get a very large negative exam effect. So I'm just narrowing the sample to people that I know applied to Noble. Very large negative effect, and again, I can make it go away by controlling for the Noble years and allowing for that to be an additional treatment effect of 0.3. Okay, and the low tier guys, it's the same story. School-specific offers. Okay, so this brings us back to AA. Low tier applicants to Noble, very negative exam school effect, explained by the very positive Noble effect. So the cross-sector substitution is a big deal in these data. Okay. Now, this raises interesting questions about, matching. So we're kind of in the business of designing matches, and parents care a lot about the schools that their kids go to. Okay. And many parents feel strongly that an exam school is the right environment for their kids, and they want their kids, to get into those elite schools, partly because they're proud of them, but partly because they think they're better. You might think that kids who are kind of well equipped for the exam school in terms of having baseline scores are more likely to benefit from an exam school. So we explore that by introducing covariate interactions, which include baseline, also other things like race in this model. And the sort of general model looks like this. There's a set of characteristics. Here's an enrollment effect for enrollment in school S. And here are interactions. So this is the effect, the vector of covariate interactions with enrollment in school S. And this allows us to discover if there's kind of covariate interactions in the exam school treatment effect. And it turns out that a very simple model explains these data. I'm just going to skip to the visual, which shows you, okay? And it kind of makes this point. This is a VIV plot, as we call it. So this is covariate cell by covariate cell. the first stage effect of different instruments in different covariate cells on noble enrollment. And this is the reduced form associated with that particular offer. Of course, if we use noble offers to instrument noble enrollment, that's kind of a straightforward procedure. That should recover that 0.4 number, okay, the causal effect of noble. And here that's just done for different covariates, and the symbols indicate what's significant. But we can do the same thing for exam school offers. Exam school offers as instruments for noble enrollment fall on that same line across covariate cells. Do covariates mediate the effect of exam school enrollment? Yes, in a very simple way. The effect of a kid with a particular, the effect of an exam school offer on a kid with a particular set of covariate characteristics is entirely explained, well, up to the precision of these set of estimates, by the noble first stage, by the effect of the exam school offer in that covariate cell on the noble enrollment rate. Another way of saying that is IV using noble offers as instruments and IV using exam school offers as instruments are indistinguishable. The exam school effect is all about noble and nothing about the exam schools themselves. We don't see any evidence of any other kind of heterogeneity. Here's two-stage least squares using noble lottery offers to instrument noble exposure, and here's two-stage least squares using exam offers to instrument noble exposure. Both of those are 0.39. Over ID asks whether they're the same across covariate cells. And then here we pool them, and the over ID test asks whether they're the same across all instruments, and we pass that. So that's a very simple world. It's kind of remarkably simple. No evidence of match effects. And however we identify it, there's basically a very reductionist view of the world here, which is when it comes to school quality in Chicago, there's really, to first order, two types of schools. There's charters and there's schools that are not charters. And all I need to know is whether you go to a charter or not. And that explains all the covariate variation that we explore and all the sector variation that we explore. It's capable of explaining sector variation because the sector is partly about substitution. Okay, so finally we can come back to Boston, and then I'll stop there and eat lunch. Okay, so we have some results for Boston, which are also consistent with this. The Boston situation is a little more complicated because we have a lot of K through 8 schools, and we have 7th grade exam school enrollment. But we looked at applicants to Boston exam schools who are enrolled in a charter school at the time that they applied. And it turns out that for those kids, though not for everybody, so we have an earlier paper which says that the overall exam school effect in Boston is 0. So kind of averaging across the district, Boston exam schools don't boost achievement. But if we look at the subpopulation that's enrolled at a charter school at the time they apply, we do actually see the same kind of negative effects, in fact, more pronounced even than Chicago. More pronounced than Chicago. So we see negative math and negative reading, and when you do the version that stacks the different application grades and outcomes, that's actually a reasonably precise effect. So that's consistent with the Boston story. The Chicago story, why is it consistent with the Chicago story? Well, Boston's urban charters are almost entirely no excuses. So they're of the kind of noble type that does very well with minority students and achievement. So that's it. Exam effects are driven by high-performing alternatives, not Sanders-style mismatch. The difference between CPS exams and traditional schools is inconsequential. Only charter schools stand out. In terms of AA, it's kind of good news and bad news. So on the one hand, people are arguing about something that's inconsequential for achievement. Maybe there are other reasons why you want your kid to go to an exam school, though we've seen similar results for college, not in this paper, but elsewhere. On the other hand, might as well send whoever wants to go because it's not going to hurt them. Not going to help them, but it's not going to hurt them. So, and then sort of stepping back, matching on covariates doesn't matter much. The idea that, certain kids need certain types of schools, we don't really see that. What we see is that it's the fallback school that matters. It's a simple school quality story. Quality is either high or kind of indifferent. AA will create more marginal admits. Does it matter where I said this already, does it matter where I get to go if it doesn't matter where I've gone? And it turns out that school quality trumps access. Then I get to play my song.
Dedicated to the late great Magic Sam.
You guys probably haven't seen
One,
it.
2, 3, 4.
Come on, oh baby, don't you wanna go? Come on, oh baby, don't you wanna go? Back to that same old place, sweet home, Chicago. 6 and 3 is 9, 9 and 9 is 18. Look there, brother, baby, and I'll see what I see. Hey, baby, don't you wanna go back to that same old place, sweet home, Chicago? Come on, baby, don't you wanna go? Well, come on, baby, don't you wanna go back to that same old place, sweet home, Chicago?
God, the mafia's after
You
us
guys
now.
were hot. You were great, insane. I've got to record you.
Bullshit.
Bullshit?
So whatever's
I don't
good there.
bullshit. I'm president of Clarion.
Blues Brothers. Whatever's good about it is going to be pretty damn subtle because it doesn't, most of what would be good in life, you would think that would be something about college and something about achievement. That's why people are keen to go to those schools because they have more resources, it would be said, or a challenging curriculum, or a curriculum that's good for bright people like you. But our claim is that bright people like you are destined to do well in life. You cannot prevent it. Even by, are you a PhD student in politics?
I'm an undergrad at college.
Undergrad, okay. But you said you want to do your thesis.
I'm doing my thesis on something right now.
Oh, you're undergrad?
Yeah.
Okay, but suppose you went to graduate school and you did a PhD in politics. You would still have a good life.
Got it.
How many students are like way above the hardest cutoff and way below the easiest cutoff?
The highest cutoff's pretty high.
Okay. So these are generalizing to the entire spectrum of.
Well, that's one of the cool things is for the schools that are inframarginal, you do get variation away from the cutoff because of the mid thing. So, suppose you rank Peyton ahead of Northside, you have variation at Northside which comes from not qualifying for Peyton. So you're not marginal to Northside. So we talk about that in another paper.
Your comment about the colleges that these students go to answers part of my question, but I'm curious about the potential for peer network effects on long-term outcomes like jobs, maybe even majors in college, as opposed to whether or not you go to college, these kinds of things. Is there any?
Well, that would be, I'm I'm not aware that somebody actually looked at the majors. It'd be hard to get the data set that allows you to do that, because you need all those applicants.
And I was wondering if you could do something with the, iPads has a lot of data on outcomes and matching.
No, iPads is not about individuals. Maybe, doesn't NSC have majors? It might actually. Does it have the major you graduate with? It might. But as a labor economist, I would say the proof of the pudding would be earnings. So I would like to look at earnings. And we're kind of trying to get that. It's hard to get permission to match into administrative earnings data. But that's a good project for graduate students. Yeah.
So is the information about tiers public? So I feel like it's a
You know what tier you're in?
Yeah, where you live.
It's novel.
What novel? So I just wonder if
you can find out. I don't think people are hugely aware.
Okay. So like you can create a weird incentive for some particularly motivated parents to try to game the system.
It happens.
It does?
Probably.
Yeah, a couple times every year someone buys an apartment in a worse
Wow.
neighborhood.
Well, I mean, that happens actually. I have a friend who lives in Cambridge, and when his kids were school age, they bought an apartment in Brookline. So, you know, if the district catches you doing that, there's some sanction for that. Probably won't be fine. But, I don't think people are hugely aware of the sense of getting a letter like you're in tier one.
It seems like there's difference between the cutoffs.
Mm-hmm. So in a table I can show you, we document how many people are affected by AA. Let's see. Yeah, so not that many people are affected by AA, so about 1,500 kids get an improved offer through AA. So AA today in Chicago is marginal. But in terms of the tier distribution, they're overwhelmingly in tier 1 and 2. Yeah.
What's Noble selecting on when it lets kids in?
Lottery.
Pure lottery.
Pure
like,
lottery.
No, nothing with any, you can attend any Noble school in the entire city if you.
Except that there's capacity constraints.
Okay. All right. So they don't consider, locality or anything. That's all. But if you
I think you have to be a resident of Chicago.
Okay, but you can attend one on the other side of school if you, town if you're. Okay.
Yeah, that's also true in Massachusetts.
Okay.
So the better states impose that sort of thing, I think.
Okay.
Massachusetts imposes, the state says charters have to admit by lottery.
Okay.
And there are places where they don't, but in Chicago they do. New York. Actually, New York has a very large screened sector, but it doesn't include charters.
Okay. Just I'm sorry, you're eating.
No, that's
it
okay.
looked like the sorry, I'm reading his chart.
Yeah.
Noble Network Lottery.
Oh, no, but this one is not the one I.
Yeah, I think the other one just has the descriptive statistics.
The point of this one is
Yeah.
that the compliers have a lot in common with the AA affected.
Okay, all right.
So these are exam school compliers, and these are people who get an additional, not that many people get an additional offer, but they get an improved offer.
Okay. Improved over the,
Improved in the sense of getting a more selective offer
okay, yeah,
by virtue of being in the tier,
okay.
low tier. Yeah, so affirmative action is politically important, but not empirically super important.
Okay.
Chicago just doesn't have that many whites. Boston has more. So Boston also has lots of Catholic school kids.
Uh-huh.
I think one of the biggest feeder schools in Boston is Holy Name.
Okay.
Okay.
And this is just like the last column. I'm reading this as shares of noble school compliers. So it's like
Those are
likely
noble instrument compliers.
yeah. So more likely to be female, very likely to be Hispanic relative to black. Or am I reading that wrong?
Yeah, that doesn't seem right. That's a good observation. That doesn't seem right. I don't know. Yeah. I hadn't noticed that. Oh, sorry. I have to think back what's in that table.
One other question. So, I mean, it seems like one of the clearest implications for parents who are making this school choice is potentially consider more heavily putting down noble schools, charter schools. Are there other implications for like parental preferences in the school match process that come out of this research?
Well, we like to say that the argument about exam school seats is a distraction from what we need is, it's the old rearranging the deck chairs on the Titanic Star. We need better boats. And we would like districts to do a better job of measuring value added. That would show that noble schools are pretty good. Not that all charters are good. There are a lot of bad charters. In Massachusetts, charters outside of Boston don't tend to be very good, actually. And so we would like the state or the city to measure school quality and to focus on making it as easy as possible to get into high quality schools. And high quality schools are not schools that have good peers, necessarily. It is very hard to convince people of that.
More substantive question. So is there a way to get at finding out what happens if you send a kid from who has a higher baseline to a charter school? Can you? I'm guessing not many. Maybe I missed that, but it seems like not many people are.
Well, that's implicit in the covariate thing.
Oh,
So
yeah, okay.
high and low baseline charter effects are similar.
Oh, okay, okay.
In our data.
Oh, okay, all right, you're right. Yeah.
In general, the no excuses schools tend to serve a mostly low achieving demographic group. But everything is relative. So this is within Chicago, where everybody's already mostly non-white, low achieving, poor. Yeah. Then if you divide those people up by its baseline, the high and low achievers will have similar effects.
Right. Okay. I was thinking more like the socioeconomic baseline of the tiers, and I'm guessing just not a lot of people from the really wealthy neighborhoods.
Mostly they're not in the public system at all.
Oh, okay, so they're out entirely.
My friends at the
religious
University of
schools.
Chicago send their kids to the lab school,
Okay.
which I think exists for that purpose. It is a faculty recruitment tool to allow people to live in Hyde Park, and which is attractive if you know the geography of Chicago. Walk to work and not have to use public transport and not have to pay for private. And my friends at Northwestern live in Evanston. So people do comment that the charter effects that we see, these are not really for children like mine in the sense that I'm highly educated, white guy, high income guy. You don't see a lot of people like me with their kids in charter school. But that isn't really what urban district public policy is about anyway.
Right. But that may be pedagogy, people who are trying to understand how to teach, might be interested if it turns out that the no excuses approach is broadly applicable outside the target audience.
I agree with that, and in fact, I teach econometrics a lot like my daughter teaches English in Dorchester. I use a lot of her methods, some of which I got from her and some of which I kind of came up on my own. I have a very structured classroom. Everybody has to look at me, no electronics. I cold call. There's assignments, and somebody even blogged about this, that Angrist econometrics at MIT, it's like a KIPP school. Somebody who I think had done TFA at KIPP.
It seems like a highly stressful environment for students.
It is.
Can you like,
That's my goal.
No. I'm sorry. I meant for your daughter educating middle school. Is that what you said? Or, yeah. So in your conversations with her, how do the students deal with that? Is what I'm saying.
They love it.
They love it. Interesting.
I would say not all the time, but mostly. My students love me, even though it's stressful. I have not a very relaxing classroom experience. And part of what's going on, I think, is that you need to work hard to keep people's attention. And so if you actually hold somebody's attention for an hour, you've accomplished something, and the time passes quickly, and everybody has a good time.
Well, so is this a story about holding the students' attention or making them work harder?
Both.
Both. Okay.
Yeah. Then they want to please the teacher. The teacher is sort of an authority figure, and they want to please the teacher. There's sort of a basic philosophy of human nature behind the no excuses, which also I think, particularly with children, but maybe with college students, the children in that environment in particular, they live in a fairly chaotic world, and that's unpleasant. And here they're in a world where the rules are clear, good deeds are rewarded and bad deeds are sanctioned.
Stability.
And it's completely predictable. It's God's world. And the teacher is attentive to their needs, but, expects commitment and so on.
One more question.
And I think the young people in particular like that idea that the adults kind of know what's going on and it's safe. The school also provides a safe environment, in an otherwise not so safe neighborhood.
I guess I'm thinking of a story that someone could try to tell about your results, and I'm trying to think through whether you think it's consistent with the results that you found. And I guess that story would be that students who are from these low-income backgrounds who are thriving at the no excuses charter schools in middle school have sort of been socialized to this very structured environment that you described, and then if they find themselves in an exam school where the sort of school culture and expectations around behavior are very different, and that is sort of why they would do worse, or part of why they might do worse at an exam school compared to whether they had continued at the no excuses charter?
That's possible. That's an alternative. Right. So that would still leave the kids who come from charter as negatively
Right.
affected. Would that match the first stage? Maybe. Maybe. Think about that. I think the flip side of that is, so you're proposing a hypothesis, which is plausible, which is there are school environments that prepare me well for an exam school, and there are school environments that don't prepare me well. Why don't I see anybody benefiting? You know, it's all mediated by the charter enrollment. So then there should be covariate groups or something, or the high baseline kids,
Right.
or the high tier kids should be doing well, but we don't see that. So I think that's somewhat indirect, but you're right that there's a sense in which you could put that explanation on top of our data. But then you would have to, I think the weakness there is, it still doesn't seem to be good for anybody.
Right.
I have another paper where we have, it's mostly methodology, but kind of RD away from the cutoff. So kids that are sort of highly inframarginal
Right.
also don't benefit. But certainly educated people really want to believe that, and you'll see when you're a parent, or maybe you're already a parent, I don't know. It's impossible to convince my colleagues of this finding.
Yeah. Well, it's possible that your colleagues' children are just not the sort of children who would be, I mean, they're the kind of lab school kids who you were describing,
Yeah.
who might actually perform really poorly in a highly structured
That's what they believe.
I mean, that may be true given the sort of Montessori type background that their children might.
And there are not a lot of people like that in the Chicago public schools.
Right,
So
exactly.
there are
So
some
you're
in
not-
Boston and New York.
Right.
New York actually has quite a large white enrollment
Right.
by the standards of urban districts.
Right.
And, Stuyvesant, the legendary Stuyvesant. If you get into Stuyvesant, you're one of the smartest people in the universe. And by definition, because New York is so big.
Right, right.
And so it's so selective. So if anybody is qualified for Stuyvesant, it's the Stuyvesant applicant who gets in.
Right.
And yet.
Right.
And that's because, Jesse Shapiro's of the world, that's just an example, highly successful economist who went to Stuyvesant. Again, he's gonna have a good life. Can't prevent it. He can't prevent it. Parents can't prevent it. My parents couldn't prevent me from it. In spite of my best effort. Okay, guys, thank you. That was